Our topic is probability. We use probability in our daily life very often, in our sentences and words actually. For example, when your friends ask you out, you may answer them differently. You may say that certainly you will come, which would indicate that 100% you will be there. Or you may say that you can maybe come, which would indicate that there is a chance you can go to the cinema with them, but it's not certain, but it's not an impossible event too. So let's look at what probability is in a more serious manner. A probability is the chance that a particular event or set of events will occur expressed on a linear scale 0 to 1. Probability can't be less than 0 or more than 1. This is an important part because there can't be an event more likely to happen than certain, or the same way there can't be an event less unlikely to happen than impossible. So simply, probability is how likely something is to happen. We use likely because many events can't be predicted with total certainty. So we calculate how likely they are to happen using probability method. Let's look at how to calculate probability. We calculate the probability of an event happening by dividing the number of ways it can happen, the number of ways the event can happen over the number of outcomes. Let's look at this formula in an example. What is the probability of rolling a number greater than 3 with a die? So first we need to write the number of ways it can happen, the event can happen, which means, in other words, the things that meet the conditions of the question. What is our condition in this question? It is that the number that we roll will be bigger than 3. So let's first write the number of outcomes, which means the number of the numbers that we can get without the condition, which is 1, 2, 3, 4, 5, and 6. All the numbers in a die. So let's look our number of ways it can happen. So we will take the numbers greater than 3, and those are 4, 5, and 6. Let's write our formula. P E equals, and by the way, we show probability by P and a letter between brackets. So PE equals our number of ways it can happen, which is 3, 4, 5, 6, over the number of outcomes, 1, 2, 3, 4, 5, 6. In the simplest form, it is 1 over 2.
Question: 2 coins are tossed. Find the probability that 2 heads are obtained. Note, each coin has 2 possible outcomes, heads and tails. The sample space S is T, H, 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 T, and T, T. E is the event's 2 possible heads.
Question: a dice is rolled.
Again, we
Find
use
the
the classical
probability
formula
that an
of
even
the
number is
probability.
obtained.
PE
Let
equals
us first write the
NE
sample
over
space of
and
the
S,
experiment,
which means
S.
and S is
1,
4,
2, 3,
and E
4,
is 1.
5, and 6.
E is the event an even number is obtained, and it's 2, 4, and 6. We now use the formula of the classical probability. P
E equals N over
There's some words we
E
need to learn to continue through this topic.
N E
Experiment,
over N
sample point,
S.
and sample
This
space.
is
Experiment is
there
an
are
action
3
where the result
E
is uncertain.
and
Tossing a coin
6
or rolling a die is an example
equals
for it.
1 over
Sample point is only one possible outcome, and sample space is all the possible outcomes. Let's look at these words in an example. There is two orange sticks, 3 purple sticks, and 5 blue sticks in a glass. So, would be our experiment in this example? It can be the probability of picking a purple stick out of this glass. As we learned, we calculate probability by dividing the number of possibilities that meet our condition by all of the possible outcomes. So there's 3 sticks, purple sticks, in this glass. So 3 purple sticks over all of the sticks, we have 10 sticks. So our probability of picking a purple stick out of this glass is 3 over 10. Sample point. Sample point can be either of the colors, either group of the colors. So it can be purple ones, blue ones, or orange ones. Sample space is all the sticks in a glass, in this glass. Let's look at events. Events are the result of an experiment. For example, getting a tail after tossing a coin is an event, or rolling a 6 is an event. There are 3 types of events: independent events, dependent events, and mutually exclusive events. In independent events, does not affect each other. In dependent events does affect each other. And in mutually exclusive events cannot occur at the same time. For example, events can include one or more possible outcomes. For example, rolling a number greater than 4 with a fair die. Our sample space is all the numbers in a die: 1, 2, 3, 4, 5, and 6. So, our sample points are only one side of a die. So, 1, 2, 3, 4, 5, and 6. They are all a sample point by themselves. And our event is our experiment results. So, our experiment is to have a number greater than 4, which so our conditions is the number to be greater than 4. Independent events. We said that independent events does not affect each other. So you roll a die 7 times and they are all 5. What is the chance that the next will also be 5? Would the probability of getting rolling a 5 increase or decrease? No. It will be the same, exactly the same as any other possibility of rolling a die, rolling a number.
Question: if a die is thrown twice, find the probabilities of getting 2 5s. P getting 5, or probability of getting a 5 on the first row is 1 over 6. First thrown, 1 over 6, and second thrown.
So we learned that
1 over
dependent events
6.
affect each other. So let's see this in an example.
Probability of
There is
2
7 red and
5s
5 blue marbles in a bag.
is
I
1
take
over
one
6
blue marble
times
out.
1 over.
Would the possibility of picking a red marble stay the same? So let's first calculate the possibility of picking a blue marble without the removal of one blue marble. So we have 7 red and 5 blue marbles. In total we have 12 marbles. So our possibility of picking a blue marble is 5 over 12. So let's look at the possibility of picking a red marble after the removal of one blue marble. I take one blue marble out. So now we have 4 blue marbles and 11 marbles in total. So our possibility of picking a red one is 1, 2, 3, 4, 5, 6, and 7 out of 11 marbles. So the probability of picking a red marble increased and picking a blue marble decreased.
Question. A purse contains 4 5 bills, 5 10 bills, and 3 20 bills. 2 bills are selected without the first selection being replaced. Find the probability of 5 bill, then 5 bill. Solution. There are 4 5 bills, and the total number of the bills in a purse is 12. So probability of 5 is 4 over 12. The result of the first row affected the probability of the second row. So there are 3 5 bills left. There are a total of 11 bills
Mutually exclusive
left.
events. We learned that mutually
Probability
exclusive events
5
are
bill
events that
after
cannot
5
occur at the same
is
time.
3
So, heads and
over
tails, for example.
probability of
You
5
can't
bill
get a
and
head and a
5
tail at
bill
the same time after tossing a coin. Or 1 and
is
3. You can't get 1 and a
probability
3
of
at the
5
same time
bill
after
times
holding a die.
probability
So let's look
of
at an example from
5
deck of cards.
bill
Aces
after
and kings.
5
These two are
bill
mutually exclusive because you can't have a
is
kings of aces.
4 over
There is no such a
12
thing. So
times 3
these
over
two sets,
11.
aces and
It
kings, don't
makes
intersect. So they can't
one-
occur at the same time. So let's look at an example from a deck of cards of non-mutual exclusive event. So we have a hearts here and kings here. So these two sets intersect, and this intersection is king of hearts. They can occur at the same time. So mutually exclusive events don't intersect. They cannot occur at the same time.
Question. The probabilities of 3 teams A, B, and C winning badminton competition are 1 over 3, 1 over 5, and 1 over 9 respectively. Calculate probability that either A or B will win.
Question,
B,
what's the
either
probability
A or
of a
B
dice
or C
showing
will
2
win,
or 5? There
C,
is
none of
or,
these
so
teams
we
will
will
win.
add them up.
P, A part of the question is
Probability
either A
of
or
2
B will
is
win.
1 over 6.
Probability
Probability of 5 is
A
1 over
or
6.
B and P, which
2
means probability
or
of A
5
is
is
1
1
over
3
6
plus
probability
1
of
over
B
6
is 1 over
equals
5. We are using plus here because the question is saying or. It makes 8 over 15. B part of the question is either A or B or C will win. Probability of A or B or C is 1 over 3, 1 over 5, 1 over 9. It equals 29 over 45. C part of the question is none of these teams will win. Now we will write
A tree diagram is a
probability
way of
of
representing
none will
the
win.
sequence of events. So let's look at this in an example. You toss a
None
coin
will
and
win.
then roll a die.
It equals
Question 1
probability.
says that what is the probability of
equals
having a
1
tail and
minus
6?
probability
And
of
means
A or B or
multiplication.
C will
So we are
win.
going to multiply the outcomes. So
Probability of
in this
A
question 2
or
it says
C
what is the probability of having a tail
B
or 6?
or C
Or means addition.
Yeah.
So we are going to add
will.
the outcomes.
It is. We find it in
Let's
the B
solve this. Let's
part.
draw a
We
tree
found
diagram.
in B part. It is 29 over 5 and it equals Question. A bag contains 3 black balls and 5 white balls. Paul picks a ball at random from the bag and replaces it back in the bag. Then picks another ball at random from the bag. A. Construct a probability tree of the problem. B. Calculate the probability that Paul picks. First part of the question A is construct a probability tree of the problem. First of all, we should draw the first row. There are 3 black balls and 5 black balls. This is black, this is white.
Let's
Now,
calculate the probability
there are
of having a queen
again
or heart. As we
3
learned,
over
we were
8
going to
black balls,
add
5
these two
over
outcomes
8
when we see a
white
or.
balls.
So
And now,
let's write it.
same thing for the white one.
Probability
3
Q
over 8
plus
black balls.
probability
White
heart.
is 5 over
But
8
there is a minus
white
because
balls.
these two
Second,
outcomes
these are the
intersect.
second
There is
rows,
an intersection
and
point
outcomes
which is
are
queen of hearts.
black,
So if we don't
black,
subtract that, we will be
black,
counting that
and
intersection point twice,
white,
which would
and
make our
black,
result wrong.
and
So
white,
we are
and white.
subtracting the ratio of queen of hearts, which is 1 over 52.
Black is 3 over 8 times 3
Well, let's
over
calculate
8
this.
is 9 over 64.
Probability
3
of
over 8
having a queen
times 5 over 8
is 1 over
is
2, 13,
15
and we
over
calculate
64.
plus
This one
1
is
over 4,
again same.
probability of hearts,
5 over 8 times 3 over 8
minus
15
1
over
over 52,
64.
which
And
equals
white
to,
is 5
these
over
are
8 times
4
5
plus
over
13
8,
over
25 over
17 over
64.
52,
Now check that probability is in the
minus
last column.
1 over 52, which equals to 16 over 52. And this, in simplest form, equals to 4 over 13. So it is very important to keep this minus in mind if the outcomes intersect. I will prove this in a minute. Prove that we need to subtract the intersection point when we are adding two outcomes that intersect. So this is our set of hearts. we have 13 hearts. This part and this part. This set is our hearts. And this set is our queens. We have 4 queens. This part and this part added is our queens. So what is this part? It is an intersection point, and as we said, the intersection point is the queen of hearts. So this is the queen of hearts. Let's look at what would happen if we just calculated the set of hearts, and the set of queens. What would happen is we would have added this part, the intersection point, 2 times, because we take this part with this set and take this part with this set too. So what we need to do is we need to add this part, and add this part separately, or add this set of hearts and add this set of queens, and then subtract the intersection. I hope it's clear.